Welcome to Lesson Digital Logic and Gates. In this lesson, we will delve into the fascinating world of digital logic and explore the fundamental building blocks of digital circuits. Understanding digital logic is essential for designing and analyzing complex electronic systems. Let's get started. Introduction to Digital Logic. Digital logic is a field that deals with the representation and manipulation of binary data in electronic circuits. It forms the foundation of modern digital systems, including computers, smartphones, and other electronic devices. At the heart of digital logic lies the binary system, which uses only two digits, 0 and 1, to represent and process information. We also rely on Boolean algebra, a mathematical framework for working with binary variables and logical operations to analyze and design digital circuits. Logic gates and truth tables. Logic gates are electronic components that perform logical operations on binary inputs and produce binary outputs. They are the building blocks of digital circuits. Let's explore some of the basic logic gates. The AND gate outputs 1 only if all of its inputs are 1. It represents logical conjunction. The OR gate outputs 1 if at least one of its inputs is 1. It represents logical disjunction. The NOT gate, also known as an inverter, produces the inverse of its input. It represents logical negation. To understand the behavior of logic gates, we use truth tables. Truth tables are tabular representations that show the output of a logic gate for all possible input combinations. Combinational logic. Combinational logic refers to circuits where the output is solely determined by the current input values. Let's explore some additional logic gates. The XOR gate outputs 1 if the number of ones in its inputs is odd. It represents exclusive OR. The NAND gate outputs the inverse of the AND gate's output. It represents a combination of NOT and AND operations. The NOR gate outputs the inverse of the OR gate's output. It represents a combination of NOT and OR operations. These derived gates expand the functionality of digital circuits and are widely used in various applications. Sequential logic. Sequential logic refers to circuits where the output depends not only on the current input values, but also on the previous states of the circuit. Let's explore some components of sequential logic. Flip-flops and latches are memory elements that store a binary value and can change their output based on a clock signal. Registers are collections of flip-flops used to store multiple binary values. Counters are sequential circuits that generate a sequence of binary numbers. Sequential logic is crucial for building circuits that can perform complex tasks and store information. In conclusion, understanding digital logic, including basic and derived logic gates, as well as sequential logic components, is essential for designing and analyzing digital circuits. To stay updated with our future content and receive notifications, remember to subscribe to our channel and press the bell icon.